looking at problem 1 from the worksheet from 7.3. So we're approximating an area under a curve. This is a parabola opening down. Y-intercept is 4. We're going to do this left endpoints, right endpoints, and then midpoints. And we're going to compare all the answers, including the average of the left and right endpoints as well. Alright, so this is the first part. We're going to do left endpoints. If we do that on this problem, actually on this one, there's one other thing we have to just be aware of. Since there's no intercepts given, we kind of have to think about what those are going to be, but in this case that's not too hard to do. In general though, you kind of need to figure out where it's going to cross the axis, the x-axis, and then that's going to be the lower and the upper bound of the integral that you're going to be setting up if you're going to be doing an integral on this. So anyway, this is starting at -2 and ending at +2. So -2 is the left endpoint. If I'm going to use a left endpoint approximation, then my first rectangle actually is not going to even have any height at all, because the output value at x equals -2 is 0. So that first subinterval, there's 4 of them. I've got one at each tick mark here. So -2, -1, 0, 1, and then 2, depending on how we shift it. We've got 4 subintervals. That first one has height 0, so I'm not even going to draw it. The second one is going to have height based on the left endpoint from -1 to 0. So that rectangle is going to look something like this. And then the next endpoint is the third one. Its height will be determined by the output at 0, which is way up there. So that rectangle will look like this. And then the last one will be determined by the height at 1, which is something about right there. And it will look something like that. My drawing's not that great, but hopefully you get the idea here. They're all supposed to have equal widths and not supposed to have kind of messed up lines on them. Anyway, so we said the first one had height 0, so let's just go ahead and write that 0. Each one has width 1 again, so really the area is basically just the height by itself, because height times 1 is just itself. So we said the first one has height 0, the second one's going to have height. What's the output at -1? Well, if I plug -1 in there, I get -1 squared. It's 1, so -1 plus 4 is 3, so its height is 3. The height at 0 is 4. And then the height at 1 is 3 as well. So my drawings these should be at the same height. So anyway, last one has height 3. So our first approximation is 7 plus 3, 10. That's a left endpoint approximation. For the right endpoint approximation, we're going to get our first rectangle will be based on this same height that we had on our second rectangle the first time, so we're going to have to go to the left to make this rectangle. It's going to look something like that. Next rectangle will be based on the second endpoint, the right endpoint at 0. Third one, something like this. And then the last one, again, that one will have height 0. So what we find here, the first one has height, we're plugging in the right endpoint, so that was a -1. We found we got 3 there, so 3 plus, and then that one had height 4. This one has height 3. And then the last one, as we saw, has height 0. So lo and behold, what do we get? The exact same thing we got before. The reason for that is that this thing is symmetric around the x-axis. That means the right half is a mirror image of the left half. Okay, so we'll do midpoints next. So for midpoints, we have to figure out what is the midpoint here. Okay, so that midpoint will be halfway between -2 and -1. That's -3/2. Next one here, that one is -1/2. This one here, +1/2. And this one here, this is 1, so it's going to be 3/2. Okay, so we base the height of each rectangle now on the midpoint. It's going to look something like this. So the second one looks something like that. Third one, notice what's going to happen if my drawing were a little bit better. We'd find that this thing It's basically exactly the same on this side as it is on the other side, and then we'll get an identical thing here. My drawing's not great, but I'm going to force it to work. I should have had this more down like that. There's the midpoint. The point is that these four should be fully symmetric on the midpoint rule. So this one and this one are the same, and that one are the same. Okay, so what's the height of the first one? So we got negative 3/2 squared plus 4. So that's going to be negative 9/4 plus 4. And so that is 7/4. Okay, now that is, this one and this one again are the same, so basically we can just double that. So we get 7/4 times 2 plus, and then we can do the same thing for these two. What are these going to be? Let's figure that out as well. So that I'm going to have to plug in 1/2. So if I do that, I'll just do that up here, 1/2, plugging it in for the x on that, negative squared plus 4. It's going to be negative 1/4 plus 4, and that is 15/4. Okay, so that's the area of these two bigger ones, and again, since there's two of them, we'll just double it to make this a little bit easier. Okay, so double that, add these all together, and we get 11 for the midpoint rule approximation. Okay, now the other part of this problem asks us to, in fact, let's go ahead and, this was part D, I guess, for that one. The part C asks us to average the answers that we got from the left and the right endpoint approximations, but you saw that those were the same answers. So if you take the average of two things that are exactly the same, you just get the same thing. So the average there, we got 10 for both of them. So comparing the two answers, the midpoint gives a slightly bigger approximate area than the average of the left and right endpoint approximations.